Okay, let's start with the simple revision or quick revision about the radiation. Do you have any idea about radiation? How can the energy transfer by radiation?
Convention and convection.
No, we said radiation. Radiation is happening where? In which state of matter?
Evaporate.
What? Sorry?
Like the radiation comes as the light from the sun.
No, the light
in
is something.
wavelengths.
Light is light and radiation is radiation. How the energy can be transferred by radiation? Okay, why? Or where? We said conduction happens in solids. Convection happens in liquids. They need a medium. But what about radiation?
It doesn't need a medium.
Yeah, it can be transferred in a vacuum like space. So we can get the thermal energy from the sun through the space, okay, to the earth. So energy from the sun reaches us from the space or from the sun as infrared or thermal radiation. And we said this infrared can travel in a vacuum as a wave. It has a wavelength, it has an energy, and what else? Wavelength, energy, and it's like the light wave.
Frequency.
Frequency, thanks Fatima. Okay, and we said all objects emit thermal radiation, but depending on what?
On their wavelengths and frequencies.
No. Think about the hot cup and the cold cup.
Depending on their temperature.
Yeah, depending on their temperature. Today we will study about cooling by evaporation. How can we cool by evaporation? In hot days, okay, and we don't have electricity, for example, some of us can wet their arms or have a shower without drying our bodies, our hands, our hair, okay? Why we are doing this? We are feeling cool. So what's the process here? What's happening exactly? Why do we feel cool by just wetting our arms or our body parts?
Because like the water, when it touches our body, like cools us.
Because the temperature of the water is different than the body.
Okay, what's happening to the water on our bodies? Our temperature is 37, okay, and the water temperature is less. So what's happening here? Think about the...
Maybe when it gets hot on your skin, it evaporates slowly.
Like when the droplets, yeah, when the droplets touch our skin, they evaporate because our body is warmer.
Cold.
Yeah,
It
cooler.
heats the water droplets.
Yeah. The energy or the heat or the thermal energy from our body gets into the water drops and make it to evaporate. So that's how can we feel cool. When it evaporates, we will feel the coolness. So in hot countries, people use cooling by evaporation to cool their houses. In old days, they didn't have any air conditioning, so they were using a wet towel on their doors, opening doors. So when the wind comes hot or the temperature is high, it hits this towel and cause the water to evaporate. So we can say the current or the atmosphere inside the house will decrease, so they will feel the cooling or they will feel the cool air comes from the door. Why do we feel cool when we sweat?
The same thing happens. The liquids from your body gets cooler when they face maybe the room temperature.
Yeah, when your body gets height, when your body increased, body temperature, sorry, increased, your body will excrete sweat, so it will cool you down. The water comes on your skin, out from your skin, and this will evaporate and make you feel cool. Other than this, the body temperature will increase and the person will die. Why do we feel cool when we wet our hands? Okay, we answered this question. Okay. Now we know how the cooling by evaporation, like why the cooling by evaporation works, but what's happening inside the drops of water? So can you tell me, how do the particles behave inside the liquid? Guys, I will open the whiteboard. I need someone to draw the water behavior inside the liquid.
How?
You can draw on my screen. I shared it with you.
No.
You can.
They slightly touch each other.
Okay. No, this is far away. You're not drawing touching. You're drawing them far away from each other.
Who's drawing?
Sophie, are you drawing?
No, I'm not drawing.
Fatima.
Fatima, are you drawing?
Someone's drawing with me, miss.
Good morning, Mohammed.
Good morning.
Okay, Fatima,
Someone
are you
is drawing with me.
With you?
No.
Yes.
You are drawing.
Yes.
Okay.
How?
Okay. Okay, it's okay. Keep it. This is far. This is far. This is far. Okay.
They said that there's like there's no much space. They are touching each other.
They are
but not
touching
in a
each
regular.
Yeah, they are not
They
in a regular
slightly
pattern.
touch each other.
Okay.
But they're not in
No,
regular pattern.
they touch each other, not slightly.
But
That's
they are
like,
not.
but they are not in a pattern. That's what makes them easy to move in and out of each other. Okay. Okay, let me share my. Okay, so a molecule inside would need to travel fast to escape from other molecules around it. Can you tell me why?
Is it because another?
What? They are because.
Is it because they can go in and?
Or maybe because of the the pressure on them.
Okay, not the pressure.
What's the question?
I
Maybe
said
how.
why they need to escape from each other. Like they need to travel fast.
Because like
Because they can go in and out of each other.
each molecule just want to get away or
Okay, why?
move fast.
What do they have that make them touch each other or like attracted to each other? They have a force, right?
Forces between particles, yes.
Okay, Mohammed, are you there?
Yes.
Okay, can you tell me, can you give me an idea?
Forces between particles.
Forces between particles hold them together. Okay, they need to escape. So they have average speed. They need to escape from each other. So if you kept a warm water, even like the temperature is normal, in a warm place, 25, which is the room temperature. Over days, or after a month, you will find the water level is decreasing, right? Or decreased. Each time
Yes, because it
decreased more and
evaporates.
more. It evaporates. Okay, what's happening exactly? Inside the liquid, we have the molecules, okay, that they need to escape from each other from the force that hold them together. So they have energy. On the surface here, they have high energy. They can escape as gas. Here in the middle, they have medium energy or medium speed that are pulled back to the liquid again here, okay? Each molecule is moving in a different direction. That's how they can get in and out of each other. One of them is getting in that direction, and one of them is getting here, going there, and one of them is up, and one of them on the right, okay? They are moving. They are like crowded people, okay? So each one of them has a speed. So on the surface, we can see that molecules have high speed. So they can escape. They can go to the surface and escape as gas. In the middle, we have medium speeded, the speed that are pulled back by the water again. And the down ones have lower energy. So in this case, they will remain in the liquid until the time passes. They will have less crowded molecules or less molecules in the water. So in this case, they can escape also. Is it clear?
Yes.
Okay. Why does water evaporate? Evaporation will happen whenever you live as long as the temperature of the air is above zero. So it takes time. If it's, for example, if it's cold place, it will evaporate, but it will take a long time than if you placed this cup in a hot weather. But it will evaporate. Above zero, it will make the water evaporate. So how the temperature of a liquid linked to how quickly the molecules in the liquid are moving. We all know that if we start to heat a cup of water or water pan, the water will evaporate, and it will evaporate quickly, right? It will boil and evaporate quickly, more than if we put it in a warm place. Okay, what's the reason here? What's the link between the temperature and the movement of the particles or the molecules?
When the temperature gets higher, the molecules, they move more faster.
Okay, okay, they move faster. What causes of this?
Like want to escape.
Okay, what's the reason exactly? What do
they get more energy.
That's good. They have more energy. They will get more energy that makes them able to move faster. Okay, so they have average speed. So this average speed, as I said, it will be higher at the surface, so they will escape. So at any temperature, some of the molecules will be moving slower than the average speed. The down ones, they will move at lower average speed because they have like crowded molecules. They cannot move faster. And some will move faster. There is a range of speed. So why do we have this range of speed? This because the molecules are colliding with each other, and the energy is transferred in those collisions. So here, if they collide with each other, okay, the energy from one of them here, from the down ones, will get to the upper ones. Let me change the color. Okay, the energy from the bottom here will get into these molecules, transfer here, transfer there, transfer here, transfer there, keep transferring to the other molecules. So they will get average speed also. That's why even they have different average speed. So in a liquid, in a particular temperature, few of these molecules will be traveling fast enough to be able to escape from the attraction of the other molecules around them. So when these fast moving molecules escape, this reduces the average speed of the molecules left behind. Okay, now we are talking about the cup in worm room.
Can you repeat that again, Sana?
We said that when these fast moving molecules escape from the liquid here, this reduce the level of the water, right?
Yes.
Yes.
Okay, when the level of the water reduce, this will reduce the average speed of other molecules that left behind, the molecules that we can see here, okay? This will decrease their average speed. So if you want to imagine this, we will have simple example about it, okay? Let's say, let's calculate your height average, okay? I need you to give me your heights. For example, Sophie, what's your height? Okay.
160.
Okay, 160. How many of you now? You are 4, okay?
168. 168.
Okay, you are 4, right? How can we calculate the average?
Add all 4
add them and
together and then divide by 4.
By this, okay.
Yes,
So,
add them and divide by 4.
okay.
Yeah.
Sophie, you said 1 point what?
1.60.
1.6.
Seriously.
68?
60.
Okay, 60. Naim?
1.68.
1.68. Mohammed?
1.60, 1.59, something like this.
Okay, 1.60, let's say. Fatima?
1.64.
What?
1.64.
Okay, so who are the tallest ones?
9.
Naim and Fatima.
Naim and Fatima. Okay, 1.60 plus 1.68 plus 1.60 and sorry, Fatima, you said 1 point what? 60?
4.
64. Okay, when we add them together, how much we get?
6.52.
What?
52.
6.62. Okay, divided by 4.
1.63.
1.63. Okay, I need now, you are 4 now, okay? I will eliminate the tallest ones. Let's assume that the tallest ones, which is Naim and Fatima,
Molecules.
the molecules with the high speed, the high average speed, okay? So if we eliminated them, we will get 1.60 plus 1.60 over?
2.
Over what?
2.
Over 2. So what can we get?
120 divided by 2.
We get 1.60.
1.60.
1.60?
1.60.
Okay. So look at the values that you got now. At the beginning, with four people, with 4 heights, okay, we got 1.63. But with 2 heights, which is the low average speed, we got 1.60. So when we eliminated these the taller ones or the high heights, okay, we got less we got less value. So it's the same thing with the fast moving molecules. We said Naeem and Fatima are the fast molecules. When we eliminate them, when they escaped from the liquid, we got only low average molecules. So the average speed decreased. Okay? Is it clear now?
Yes.
All of you?
Yes.
Okay. Okay. So that's how the average speed can.
Yes, it's clear.
Okay. So do all molecules move at the same speed? We discovered that they don't. Each one of them has energy and different speed. They have different average speed. Some of them are moving slow, some of them are moving fast, and some of them are moving in a medium speed. The molecules in the liquid have an average speed that depends on the temperature of the liquid. So as we said, if they have high temperature, that means they will get more energetic. That means the average speed will what?
Okay.
If they got more energetic, the average speed will increase. If the average speed of the molecules in a liquid lower, this means that the liquid is cooler. Why?
Because the molecules are
Because they have
don't have
energy. So
They don't have that
have
much
they
energy.
have less energy, so
Yeah.
so the speed will be lower.
Will decrease. Yeah, the speed will decrease, and that means the liquid is cooler now. Okay, how can we use cooling by evaporation and where? Cooling animals. Guys, we studied before about the fennec fox, okay? And we said the fennec fox has a very big ear. This fox lives in the desert, but it has very big ears, huge ears compared with his size, okay? So we said these ears for cooling. How can his ears designed for cooling? Be designed for cooling?
Shine out, like protect him from the sunshine.
No, we said for cooling.
For cooling.
Yeah,
his face is bared, so it can.
It like helps it to sweat more.
Yeah, that's
like
good.
That.
It will sweat from his ears. It's like the dog. We all know that the dog is sweats from tongue, right? Or
yes.
Okay, so that's why it keeps like his tongue out. So a dog will pant, which is like getting his tongue out and like having a like a deep breath, okay, like fast breath, okay. This help it to cool down. Water evaporates from its tongue. Elephants cannot sweat, so what they are doing, they get into the lake, and they are taking this water and pouring it on their bodies. So elephants will use water on their skin to cool down because they have rough skin. They don't have smooth, and they have very thick, rough skin. So it's hard to sweat from that skin. So that's why they are pouring this water on their bodies it's like sweating to cool themselves down. Evaporative coolers and refrigerators. So how these evaporative coolers and refrigerators work? In an evaporative cooler, fan blows warm water, thermal energy is transferred to the water, it evaporates, and the air cools down. So the cold air circulates around the house. Before inventing these air conditions, they were using these fans, okay, because they didn't have these air conditions. They were using water inside it, okay. So this fan can blow this warm water and cool it. So the warm water will evaporate by the fan, will evaporate and cool down the house. It's like the wet towel. It's like the sweat, transferring the energy from the warm side to make the water evaporate, and in this case, it will cool down the surroundings. Okay. What about the refrigerators? A special liquid called a refrigerant is pumped around tubes at the back. We all know from the back of the
Yes.
of the
Yes.
fridge, okay, we have like pipes like this, right? And sometimes like this, okay? These are using a special liquid inside them, okay, that circulate around the inside these pipes. When it circulates in these pumps, thermal energy from inside the refrigerator evaporates. So that's why you can open the refrigerator. Sometimes you can see droplets of water, okay? If the electricity is off and you open the refrigerator, you can see water inside it, right? That means what?
Yeah.
That means the temperature is increasing. So the water condensated again. But when it keeps circling, yes.
Why like the fridge and the freeze, like freeze is more colder? Is it
Why?
because more gas or more this substance going to that place?
The temperature. This is because of the temperature. This is designed with very low temperature, below zero, and the other one with little bit higher temperature, like between 1 and 5 degrees. So
We can say it's like separated.
They are separated, yes, each one of them with the special like cooling system.
Oh, great.
Okay, so the refrigerator will not freeze. Some of them have small, the small refrigerators, they have like very small freeze inside them. So it will just freeze anything inside it, but the other parts will be just cool. Okay,
Great.
so here we said this tube, the thermal energy inside it will evaporate the refrigerant. This cools down the inside of the refrigerator. Air conditioning works at the same way. If you notice that the air conditioning, they have the same tubes from inside, okay? They have the same tubes. They have this special liquid inside them. So when the thermal energy gets into the liquid will evaporate and it will cool down. It will send or emit a cool current around the room. So this is how the cooling by evaporation works. So liquids, the summary of the lesson is liquids evaporate when fast-moving molecules escape. So when they escape, this is evaporation. Evaporation cools the liquid. Why? Because it will escape and decrease the temperature. Evaporative coolers transfer energy from the air to a liquid to cool the room. So that's how the evaporation works. Do you have any question about this?
No.
Okay, guys, I need you to do something for me. You have the review question in page 226, 227, okay? I need you to solve the questions that related to the lessons we have learned or we have studied, okay?
Okay.
And also the yellow
Okay.
box, please. So next time when we finish our lessons, we will solve them and we will revise them together, okay?
Okay, tamam.
Okay, see you next time. Bye-bye.
Have a good day. Bye.
Bye.